Hello everyone, welcome to In 5 Minutes. In this video we are going to see the type 4 of higher order differential equation, that is x is e raised to ax into v, where v will be some function of x. In general, the higher order differential equation is given by f of d into y equal to x. In our case, x is e raised to ax into v. The solution for this equation, as we all know, is given by y equal to yc plus yp, where yc is the complementary function which is same for this type also as we used to calculate for other types. In this case, yp will be 1 upon fd into x. So what is x? X is e raised to ax into v, where v is also a function of x. So whenever we have these terms, that is e raised to ax into some function of x, and then we take this e raised to x out of the function of fd. So we will get e raised to ax. When we take this e raised to x out of this f of d, then we replace d by d plus a, where a is the coefficient of x in e raised to ax into v. Then we solve only this part of the equation as we used to solve for type 1, 2 and 3. Okay, so this is the type 4. This will be more clear when we see the problem on this. So solve this. As you can see, in this equation we have e raised to x into x square. So it is equivalent to e raised to ax into v, where v is x square and this is e raised to x ax term. So this equation is of the form x equal to e raised to ax. Then our solution is given by y equal to yc plus yp. First we will calculate what is yc. For that we will consider an auxiliary equation. What is auxiliary equation? Auxiliary equation is nothing but f of d equal to 0. This is our f of d. So d cube minus 3d square plus 3d minus 1 equal to 0. We need to find the roots of this equation. If you see this is nothing but d minus 1 the whole cube equal to 0. This is equivalent to a minus b the whole cube, which is equal to a cube minus 3a square b plus 3ab square minus b cube. If you expand this d minus 1 cube, you will get this equation. So d minus 1 cube, from this we get d equal to 1, d equal to 1 and d equal to 1. So we get repeated roots and the roots are repeating thrice. Then in this case our yc will be given by c1 plus c2 plus c3. Because the roots are repeating thrice, therefore 3 constant. We multiply one constant by x and other constant by x square into e raised to m1x. In our case m1 is nothing but 1. So e raised to 1x. This is our solution for yc. Now we will find yp, which is equal to 1 upon fd into x. In our case x is e raised to x into x square. And what is fd? fd is d minus 1 the whole cube e raised to x into x square. As I have told you, whenever we have e raised to x and some function of x, we take this e raised to x out of the function of d. So we get e raised to x, and then we replace d by d plus a. In our case, a is nothing but coefficient of x, which is 1. So we will replace d by d plus 1. So we have taken e raised to x out of the operator d minus 1 the whole cube. Then we will replace d by d plus 1, and this minus 1 will remain as it is, the whole cube into x square. Okay, so this term will become e raised to x into 1 upon d plus 1 and minus 1. So minus 1 and plus 1 will get cancelled. So here we have d cube into x square. What is 1 upon d cube x square? 1 upon d represents a integration. 1 upon d square represents a double integration. Then 1 upon d cube represents a triple integration. So first we will take a single integration of x square, which is nothing but x cube upon 3. Then we take the second integration of x square. So second integration of x square will be x raised to 4, and this 3 will remain as it is upon 4. Then we take the third integration, which will be x raised to 5 upon 5, and this 3 into 4 will remain as it is, which is 12. So 1 upon d cube is nothing but x raised to 5 upon 12 into 5 is nothing but 60. So this term is nothing but e raised to x into x raised to 5 upon 60. So this is our yp. How to do this integration? First we take the integration of x square. So the integration of x square is nothing but x cube upon 3. Then again we take the integration. So it will be x raised to 4, and this 3 will remain as it is upon 4. Then we again take the integration. It will be x raised to 5 upon 5 into this 3 into 4 will become 12. So this is how we take the integration. So this is the solution of yp. Then our final solution will be given by y equal to yc plus yb, which is equal to c1 plus c2x plus c3x square into e raised to x plus e raised to x into x raised to 5 upon 60. So this is our yc and this is our y. So this is how we solve the problem on higher order differential equation type 4. More such problems we will see in our next video. So stay tuned for our future lectures.